Good morning, students. Now we can see convolution integral. Okay. Convolution is nothing but you take a system. The system is denoted by H. You apply input x of t to the system. H of t denoted for the system. It will give the output as y of t. So y of t is equal to x of t convolution with h of t. So this is the formula for the convolution. Integral minus infinite to plus infinite x of tau h of t minus tau d tau. Okay. So the convolution is used for many applications in digital signal processing. Now, and communication systems also. These are all the properties of convolution. First one, commutative property. X of t convolution h of t is equal to h of t convolution x of t. Either you can do this way or this way. Okay. Then associative property. Associative property is x of t convolution h1 of t convoluted h2 of t is equal to x of t convoluted h1 whole signal convoluted with h2 of t. Then third one is distributive property. X of t convoluted h1 of t plus h2 of t is equal to x of t convoluted h1 of t plus x of t convoluted h2 of t. So this is the properties of convolution. Next, this is also the property, but if we connect two system cascade or series, how the convolution process is obtained. Okay. This is one system. If two systems are connected in series or cascade, this is h1 of t and h2 of t. So what we will get means x of t, okay, convoluted with h of t is equal to u of t. H of t is nothing but h1 of t convoluted to h2 of t. Clear? So the whole thing can be written as h1 of t convoluted h2 of t, or by using the commutative property we can write like this. So this is same as the associative property. Now you come to the systems in parallel. Okay, if two systems connected in parallel, how do you get the output? Input is same, but it is given to two different systems. The output is added, it will give the output as y of t. Now, so h of t is equal to h1 of t plus h2 of t. So this is similar to distributive property. Okay, so systems in cascade is the associative property. Systems connected in parallel is nothing but distributive property. Now, how do you calculate the convolution integral? So, formula is given here. These are all the steps to perform the convolution integral. Input denoted by x of t and h of t. Output is represented by y of t. Step 1. So, whenever the signal is given, first we have to plot x of tau and h of tau, or replace in the given signal t by tau. You will get the step 1. Okay. Now the step 2 is fold h of t or reflect h of t, h of tau, or time reversal h of tau. Time reversal, it's nothing but mirror image. Okay. So this is reflection. Okay. First step h of tau. That h of tau is reversed with respect to the x-axis. The third step, shift h of, that is time reversal signal by t units. Okay, where the small t is minus infinite to plus infinite. So the shift h of minus tau by t units is nothing but either you can do left shift or right shift. Left shift is nothing but t is negative values. Right shift is nothing but t is positive value. The fourth step, multiply h of t minus tau and h of x of tau. Okay, that is x of tau is the signal, then h of t minus tau is the shifted signal, either it may be left shift or right shift. Multiply these two, we will get the final solution y of t. So these are all the steps to perform the convolution integral. Now we can see the problem number 1. Okay, convolve x of t equal to e power minus at u of t and h of t equal to u of t using graphical method. Graphical method is nothing but we have to draw graphical in nature. You take the first problem, x of t equal to e power minus at u of t. You draw the exponential signal, everyone you know it. At t equal to 0, the amplitude becomes 1. You will get the signal like this. Now you take the second signal, h of t is u of t. So draw the unit step signal. So this is for the given mathematical representation. First we draw the graphical representation for the given signal. Okay, now we can see step 1. So the step 1 is nothing but replace t in the given signal by tau. Okay, or plot x of tau, plot h of tau. Okay, so wherever the t is present in the given signal, just you replace by tau, you write it and plot the same. Okay, mark x-axis is tau, y-axis is x of tau. Similarly, for this signal, tau, here h of tau. Okay, the first step is over. The second step, fold h of tau as shown. Folding is nothing but time reversal operation. So you take h of tau. Already I told you it's a time reversal is nothing but about the origin it is mirror reflection. Okay, so this signal is you will get the reflection signal or time reversal. Now you multiply x of tau and h of minus tau. So the x of tau is here, h of minus tau is here. Multiply these two, we will get this answer. Multiply x of tau, h of minus tau. Okay, the product is drawn here. This is the product of h of x of tau, h of t minus tau. Okay, at t equal to 0, here at t equal to 0, okay, you see both signal, the amplitude become 1. Okay, that is written here. Okay, the first step, that is step 2 is over. Step 3, shift h of minus tau by t units where t is minus infinity to plus infinity. So what we have to do? Shift h of minus tau by t units left side and right side. Already I told you left means t is negative value, right means t is positive value. Okay, here different types of shifted signal is given for your reference. Okay, in the negative side. So this is h of minus tau. Okay, t units we have to shift left. That is the first part. Okay, t units the signal is shifted. Compare these two signal, it is shifted. Then again this whole signal is shift left. Okay, then one time shift towards the 0. This is second time. This is third time. Compare these three signal. Okay. There are the product between x of tau and h of t minus tau. At each and every step, there are no common signal. This is input. This is h of t minus tau. No common area. What will happen? The product will be 0 for t is less than 0. So, the t we placed only in the negative side. Is it clear? Okay, there are no common area between x of tau and h of t minus tau. So, x of tau is given in a green color, that is blue color. H of t minus tau is a green color. So, these two colors are not merged. The output will be 0. Now we can see the next step. Okay, here multiply h of t minus tau and x of tau. Use convolution integral and get the solution. Okay, here if t is greater than 0, what we have to do? Right shift. Okay, so the t can be placed at right side from in 0 to infinity at any place. Okay, you look at the blue color represents x of tau. The green color represents h of t minus tau. First, I am keeping the t is this portion. Okay, this portion. Now, the shaded area is nothing but, the shaded portion is nothing but common area between both the signals. Okay, what is the amplitude? This amplitude is 1. This is exponential. Okay, e power minus tau. Okay, e power minus tau. And what is the limit? 0 to t. So, for this signal, this is the limit. Now, similarly, little bit you shift the signal, you will get this part. Okay. So, if the signal is moved towards right, you look at it, the common area is little bit increased, but the amplitude remains same, the limits remain same. Okay. So, you look at it, the limit. Similarly, this is first step. Second step, this is third step, little bit you increase it, still here also. Okay, so for force 1, 2, 3, 4, you look at it, the lower limit is 0 for all the 4 cases, the upper limit is t. Okay, you look at the formula, upper limit is t. What is the amplitude? One signal amplitude is 1. This is for h of t minus tau. Now, the input signal is e power. This is input signal. Okay. This amplitude is e power minus a tau u of tau. Okay. U of tau is 1. So, this it is written here into d tau. Okay. So, this is the amplitude of the signal you have. The merge area. That is overlapped area. Okay. Now, you integrate it. Substitute the upper limit and lower limit. You will get the answer for the first part. Okay. Now, you take y of t is equal to, okay, if it goes till infinity, this concept remains the same. So, the final answer is y of t is equal to 1 by a, 1 minus e power minus at. The limit is 0 to infinity, full positive values. At negative values, the amplitude becomes 0. So, if you take t equal to 0, the amplitude becomes 1. Okay, so this is the concept behind. If you substitute all the values, you will get the waveform is like this. Okay, so this is the convolution problem. Now we can see the second example. Okay, so the previous problem, one infinite, that is two infinite signal. X of t is also infinite, h of t is also infinite. If you convolve two infinite signal, the result we discussed in the previous slide. Now this problem is to convolve finite duration sequences. Convolve x of t equal to 1, t is 0 to 1, t lies between 0 to 1. H of t, the amplitude is 1, t lies between 0 and 1. Okay, so the same concept, the first step, plot x of tau and h of. Okay, here the t is replaced by x of tau and h of tau. So the first step is over. The second step, what we have to do? Fold h of tau. So this is h of tau. Fold it. Folding is nothing but time reversal. So at a mirror image, you will get this one. Okay. The next one, product h of minus tau with x of tau. Thus, that will be given for you. So, if you multiply these two at t equal to 0, you will get the amplitude is 1. This is the portion. So, that can be written it here at t equal to 0. So, the step 2 part is over. Now, we come to the step 3. Now, shift h of minus tau by t units, either right shift or left shift. Right shift means t is negative value. Left shift means t is negative value, right shift means t is positive value. Okay, first we have to do left shift. Look at the waveform. Here the blue color represents x of tau, h of t minus tau is the green color. Okay, so in the signal you shift the whole signal by t times. Already I told you the x-axis, the 0 you add plus t, the minus 1 you add plus t. So you will get like this. Okay, t minus 1 t. Look at it. The next slide is shift h of minus tau by t units. Okay, little bit the h of t minus tau is okay moving towards right, but the t will be placed at the negative left side. Okay, at the negative axis. You look at the waveform. So the three waveforms, first one and the second one and the third one. So the t is moved towards right, but the t can be placed at the negative side. Got it? You look at the three waveforms. There are no common portion between the green signal and the blue signal. So the product will be 0. That is given here. Okay, at t is less than 0, the product will be 0. This meaning is no common portion between the x of tau and h of t minus tau. Now you come to step 4. Multiply h of t minus tau and x of tau. Use convolution integral and get the solution. Now we are going to see the right shift. Okay. So now t is move towards the right. Okay. Right means is nothing but positive side axis. First you place t is like this. Okay. Now this is the common portion. Okay, this is the common portion. Now, what is the limit? 0 to t. What will be the amplitude? 1. Okay. Similarly, the t is slightly, you move it. You come this point. This is the first diagram. Okay. So, this is the second diagram. You look at it. What will happen? Little bit the t is moved. This is third diagram. Okay. Till the t move towards the right. Okay. now it will come to this part. So till this one, fully it occupied. What will be the lower limit? 0. What will be the upper limit? T. What will be the amplitude? Both is 1. Okay. Now you integrate it. Substitute the lower and upper limit. This will be the answer for till this portion. Okay. The next one. Still you move towards right at the T end. Okay. So this part is 1. This part is 2. Okay. The T placed after the 1. Okay. Now what will be the common portion? This is the common portion. Similarly, little bit the signal is moved towards right. You look at the common portion. Okay. Now what will be the limit? Lower limit is T minus 1. The upper limit is upper limit is 1. The lower limit is T minus 1. What will be the amplitude? Is 1. Okay, now you integrate it. Substitute the lower limit and upper limit. This will be the answer. Okay. Now, the final, if you move, keep on it, there will be the no common area. Okay. So, now the final answer is concluded. Y of t is equal to, from step 2, 0, t is less than negative values of t, the amplitude becomes 0. Now you take t lies between 0 and 1. This is step 4. So 0 and 1, the amplitude becomes t. Here 1 to 2, the amplitude becomes 2 minus t. After then 2, okay, wherever you keep, there are no common area, the amplitude becomes 0. Okay, so this is the final output. Each and every value you substituted here, you can get the graph like this. Okay, for example, if you take t is 1, you will get, that is t is 1, amplitude become 1. If I take t is 1, you will get 2 minus 1, the amplitude is 1. If I take t is 2, if I substitute it here 2, what will happen? Y of t become 0. So after 0, okay, after t equal to greater than 2, the amplitude becomes 0. That will be marked here. Okay, so this is the convolution integral. Thank you.